Introduction. A matrix of rock material and rock discontinuities is referred to as a rock mass. The fact that rock specimens are limited in size means that they represent a very small and highly selective sample of the rock mass from which they were removed is a major weakness in laboratory testing. In a typical engineering project, the laboratory samples tested account for only a fraction of 1% of the total volume of the rock mass. Furthermore, because only those specimens that make it through the collection and preparation process are tested, the results of these tests are highly biased. Continuum mechanics can predict the behavior of intact rock material, but most rock masses are highly fractured. The fact that mechanical response of rock masses are controlled by fractures makes determining their mechanical behavior difficult. There are two objectives of this study. First, it is to determine the rock mass characteristics, and secondly, it is to determine values for a set of rock parameters. The importance of rock mass properties are: it provides a basis for understanding the characteristics of each rock mass class, derive quantitative data for engineering design, recommend support guidelines for tunnels and mines, relate their experience on rock conditions at one site to the conditions and experience encountered at other, and finally provide a common basis for communication between engineers and geologists.
A methodology for strength characteristic of rock mass. Since a rock mass essentially consists of intact rock permeated by joints, it guards not only the intact mineral characteristics and discontinuities, but also the way in which they are integrated. Thus, when the properties of a granite mass are given, many complications arise, such as an intact rock invariant and inhomogeneous. The discontinuities, for example, are more than 10 characteristics of derivation, and the discontinuity geometrical arrangement is varied indefinitely. Rock mass index applied as input to the Hawk-Brown-Feller criterion as RMI express the relative compressive strength of rock mass. It represents a special case in the Hawk-Brown-Feller criterion of rock mass. From the formula given, S is a constant representing the rock mass properties.
My name is Muhammad Hasib bin Ma'anis. I will present about literature review. Number 1 is deal with the overall effect of four main mix were used to compare gradation, quantity and size. The compressive strength of mixes with smaller aggregate size was found to be greater in the research. Number 2, mass concrete's compressive strength laboratory tests were used to determine the compressive strength of mass concrete in dams, and the findings revealed that there is a considerable size impact. The impact of coarse aggregate morphologies on the strength and permanent deformation behavior of unbound aggregate materials. And number 4, drilling in underground mines can be dangerous because of rock strata and the strength of the rocks beneath the surface. Last but not least, number 5 is distribution of aggregate particles in matrices is the aim of random mixing processes, according to the publication.
Hello, my name is Natia Najwa with matrix number AF1900270. Today I will present about result for this project geology. In determining rock mass index, there are two things that needs to be considered, which is jointing parameter and compressive strength. This figure will show the main inherent parameters in the rock mass are applied in the RMI. This figure will show the relation between block volume RQD and JC in determining the jointing parameter. Beside this figure, we can calculate the jointing parameter and other parameter by manually using this equation. This is the result of related to rock mass strength based on RMI value that we get based on the calculation.
Okay, my name is Simpakindora Atira binti Surizam. Number matrix AF 190109. Okay, I will talk about discussion. After the results, we can see that the rock mass index, which is have the value of 3, 0.1 or and 39 and 19. This is the value of we can know the strength of the rock, which is increase the rock mass index. The strength of the rock will very strong, and we can see at the figure 1 at value of 3 the rock is strong, but in value of 0.1 the strength of rock is weak, and when the value is 39 and 19 the strength of the rock is very strong. That we can conclude that the highest rock mass index value, so this increase the strength of the rock. Okay, thank you.
For the conclusions, rock engineering is mostly dependent on input data derived from observations and simplified measurements of the rock mass. Rock engineering is a new field for engineers who want to improve building safety, because rock mass is a big factor in the accuracy of rock-to-rock mapping. The quality of the input data has such a big impact on the effectiveness of the design's effectiveness. There is a lot of need for improved rock mass descriptions and practical recommendation. That's all from us. Thank you.